Hello, we're Team J3S1, and this is the DePing demo. Need to locate an IP? We've got the answer. Now let us introduce you to the DePing network. This is DePing, a decentralized IP geolocation AVS built on user-restaked LSTs. Stake GeoSol, restake with purpose, and help power the physical internet layer. DePing is a decentralized IP verification AVS powered by user-restaked GeoSol. Probes verify IPs in real time and are rewarded or slashed based on accuracy. It's permissionless, incentive-aligned, and designed for DPIN and DID use cases. Now let's talk about why it matters. IP data is crucial in Web3 for validator decentralization, compliant dApps, and Sybil resistance. But current IP systems are centralized, outdated, and easy to spoof. That's why Web3 needs a decentralized, verifiable IP protocol. Let's break down the architecture behind DePing. This is the DePing network. Our probes, GPing and TPing, verify IP location data in real time. We run our own router, which connects to GPings, and each GPing connects to TPings. GPing is a staked probe node that coordinates with TPings to verify IP geolocation. TPing is a lightweight probe that performs pings and reports latency and GPS. To become a TPing, it restakes GeoSol into a GPing and submits reliable data. Now let's walk through how DePing works, starting with the delegator. Delegators restake GeoSol into a GPing. In return, they earn a share of the GPing's fees, enabling a real restaking-based AVS model. Next, customer. Customers request IP geolocation from the DePing router and pay fees in GeoSol. The router forwards the query to GPings, which return signed, real-time IP proofs. Finally, the router sends the verified location result back to the customer. Now comes the most important part, how DePing ensures trust through decentralized node consensus. The DePing router prioritizes GPing nodes with the most GeoSol, sending RPC calls starting from the highest staked ones. GPings with more stake get more opportunities to respond and earn rewards. The router keeps a full registry of active GPings to route queries efficiently. Each GPing is linked to a group of TPings. TPings continuously poll their GPing for new IP queries. When a query is detected, TPings ping the target IP and return two values, the latency and their GPS coordinates. Once the GPing receives responses from at least 2/3 of its TPings, it picks the one with the lowest latency, signs its location, and prepares the proof for submission. Once a GPing selects the best TPing response and signs its location, it doesn't broadcast the answer immediately. To submit an official result, the GPing must first acquire a lock on a shared etcd token. This lock gives it permission to submit for that query round. After broadcasting the signed result to other GPings, each GPing compares it with its own independently gathered result. If the answer falls within an acceptable margin of error, the GPing votes yes, otherwise it votes no. If a majority of GPings vote in favor, the result is accepted as valid and returned to the DePing router as the final geolocation proof. If not, the round resets. The submitting GPing is slashed for submitting an incorrect or unverifiable result, and the etcd token is returned to the pool. At that point, all GPings, except the one that was slashed, can race to claim the token and submit a new answer for the same query. Now let's move on to the next part, economic flow. Our revenue model is built around GeoSol. All query fees are paid in GeoSol or other LSTs. MEV rewards from restaked GeoSol can also support the system. Around 5% of query fees is taken as a protocol fee to fund development, operations, and security. The rest is distributed. Half goes to the node that submitted the accepted location, and the other half is split among validated voters. Delegators and TPings also share in these rewards. And while this is our default flow, it's flexible for future token strategies. We're almost there. Let's get into the use cases. Our network powers decentralized VPNs, DID, validator audits, geofenced dApps, and node marketplaces, all through verifiable IP data. And now, last but not least, here's what makes DePing uniquely positioned in the Solana ecosystem. DePing is the first AVS on Solana to deliver real-world utility. It verifies IP locations on-chain as a practical DePing use case, powered by restaked GeoSol. It brings the AVS model popularized by EigenLayer into Solana, where it hasn't existed until now. Instead of building new primitives, DePing uses proven infrastructure like GeoSol, validator delegation, and staking vaults. GeoSol isn't just accepted. It powers staking, fees, and rewards across the protocol. By giving GeoSol a new purpose, DePing directly adds value and demand to the Solana LST ecosystem. It's also fully composable with Solana's DeFi and restaking protocols, from Geo to Sanctum. As a natural fit for Sanctum's Infinity Suite, DePing can enable dynamic delegation and liquidity routing for LSTs. And because DePing is built to be compatible with professional node operators like Fragmetric and broader restaking flows, it opens the door for meaningful AVS performance at scale. I hope this gave you a clear picture of what we're building. Join DePing to validate the physical layer of Web3 and collaborate with Geo and Sanctum to push the boundaries of restaking and DePing infrastructure. Thank you. GPing 1 to 5 are initiated and connected, with the proposal GPing declaring itself as the proposal to start the network. The user utilizes the DePing service to request location information for a specific IP address. TPings request the latest IP from GPing, ping it, and send the response time and their GPS data back to GPing. GPing aggregates the received data, determines the shortest response time as the answer, and the proposal GPing broadcasts it to all GPings. Once consensus is reached, the answer is returned. The router then uses the returned GPS data, latitude, longitude, to derive the location information and delivers the requested IP's region name to the user.